New discovery in space. Who would have thought our galaxy is never-ending? New parts are discovered each day, leaving us curious for more. Just 3 minutes ago, Voyager 1 just turned back, and it seems it brought with it a terrifying discovery. Let's look into the details. Voyager 1, NASA's venerated spacecraft that was launched more than 50 years ago, recently turned back towards Earth, revealing a terrifying finding as it crossed the interstellar region. The people have begun to learn about the heliosphere's move into the expansive interstellar region and about the universe after this amazing thing happened. Scientists were expecting to observe a shift in the magnetic field direction when the spacecraft moved from the Sun's magnetic field-dominated region to the one influenced by other stars. However, no remarkable shifts were noted in the magnetic field as Voyager traversed the heliopause, astonishing scientists. Scientists debate whether the probes remain within the heliosphere or if escalating galactic cosmic rays and plasma density indicate their departure. The spacecraft NASA deployed 45 years ago continues to travel vast distances despite utilizing aged technology resembling an antique record player. The lack of detectable modifications to the dominant magnetic field perplexed scientists as the Voyager probes exited the heliopause. The spacecraft Voyager 1 pierced the heliopause on August 25, 2012, and relayed interesting facts. The ambient magnetic field exhibited no noticeable shift. Voyager 2 reached a distant point of 120 astronomical units from Earth, and scientists were confused by the lack of magnetic field shifts. The available frameworks couldn't fully reconcile this divergence. The Voyager mission reveals striking insights into minute changes near the heliopause, with the magnetic field displaying little variation. The probe's equipment underwent a rigorous review when passing through the asteroid belt. The spacecraft had to withstand high radiation, cosmic rays, and small space particles' occasional hits. Each successful maneuver and every moment the Voyagers spent in the asteroid belt displayed the craft and its designers' skill and toughness. When Voyagers traveled through the asteroid belt, they successfully marked a significant achievement in their journey to the heliosphere's outer boundary. At the moment of reaching the heliopause, Voyager 1's important and historical voyage marked a remarkable occasion that was eagerly anticipated by researchers who were eager with excitement and curiosity. At the intersection of the solar wind and interstellar medium, the heliopause is located. The magnetic field is predicted to experience an observable change in orientation right now, which would indicate a move away from the familiar magnetic setting of the solar system towards the random and unpredictable magnetic environment of interstellar space. Although scientists were surprised, they were delighted when the Voyager probes reported no substantial changes in the magnetic field at the heliopause. They eagerly await the day when they can solve this mystery. Understanding the influence of the magnetic field at the heliopause necessitates examining the heliosphere, which is significantly shaped by the Sun and spans a vast area. The Sun's solar wind stretches out its magnetic field lines into an extended, elongated structure shaped like a tear called the heliotail. The magnetic field inside the heliosphere guards our solar system against dangerous cosmic rays from supernova and other extraterrestrial occurrences. Voyager 1 traveled away from the Sun and was subjected to a drop in solar wind force, ultimately reaching the heliopause. At this boundary, the solar wind's power fades, and the interstellar medium asserts its influence. The magnetic field's transformation would be triggered by the expectations of the scientists that Voyager would enter interstellar space and shift from solar to interstellar dominance. The spacecraft entering the interstellar region would demonstrate such a change in magnetic orientation. The heliopause's absence of observed magnetic field variations perplexed researchers, who put forth a number of hypotheses to account for this. A hypothesis suggests that the Voyagers may still experience the residual solar wind even after leaving the heliopause, which causes minimal shifts in the magnetic field direction. In this scenario, the heliopause might be a more gradual shift area rather than a distinct barrier. So the Voyagers have entered an interstellar region. However, they could be faced with a complicated magnetic field there. Interstellar magnetic fields may exhibit complicated patterns and oscillations. Though the Voyager's equipment is adequate enough to spot little variations, the magnetic field has seemingly stayed constant. The wealth of data accumulated by Voyager 1 has verified its journey into uncharted territory, an extraordinary moment in cosmic exploration. Voyager 1's passage through the heliopause has been confirmed by observations of augmented cosmic rays and higher plasma density, along with other markers. However, amidst these groundbreaking discoveries, one puzzling paradox remains. Voyager 1's persistent magnetic field direction in interstellar space is a mystery. Several possible reasons have been put forth to clarify this puzzle. A theory proposes that Voyager the 1st of May continued to be partially affected by leftover solar wind beyond the heliopause. The changeover might be less pronounced, with fewer extreme variations in magnetic field orientation. The slow modification might create a security zone where the magnetic field direction persists relatively unchanged until more notable shifts occur beyond interstellar space. While the enigmatic behavior of the magnetic field remains unresolved, other evidence provides persuasive evidence that Voyager 1 has entered interstellar territory. The spacecraft's findings of augmented cosmic rays and plasma density at the heliopause suggest its breakthrough to interstellar space. The proper answer to this riddle is that the Voyagers could still possibly be within the heliosphere partially. In the heliopause area, the solar wind meets with the interstellar medium. The transition from the sun's impact to interstellar space will take some time, according to scientists who believe that Voyager 1 is still subjected to the solar wind, but to a weaker degree. Voyager 1 approaching the interstellar medium saw minimal variance in the magnetic field, adding an additional layer of mystery. This observation overturns existing notions and emphasizes the complexity of the region past the heliopause. Despite being outdated in technology, the Voyager missions still surprise us and teach us important lessons about space. This durable spaceship has surpassed all predictions and has become humanity's most distant representative in outer space. They have a gold record with them, a time capsule containing audio and pictures from Earth, with the intention of communicating with any prospective extraterrestrial civilizations they may encounter throughout their voyage through the Milky Way. Voyager 1 provided invaluable insights into the edge of our solar system when traveling through the heliosphere, the area influenced by the sun. The spacecraft crossed the periphery of the solar system into unknown space. A turn towards the Milky Way's galactic neighborhood is foretold for the Earth's magnetic field. The Voyager 1 showed no substantial alteration in its magnetic field at this momentous time. Scientists have been debating this unexpected finding. Whether the spacecraft has actually entered the real interstellar space or not is still in doubt. The region where the effects of the solar wind become weaker and the interstellar medium takes over is called heliopause. To comprehend its observations and verify that it has genuinely crossed interstellar space, Voyager 1's position relative to the heliopause is crucial. The transition between the heliosphere and interstellar space and the confines of a fishbowl is like a fish's curiosity. The heliosphere safeguards the solar system from hazardous cosmic radiation and particles originating from afar, though we cannot determine its particular shape and location due to the perspective that we have within our solar system. A probe located outside of the heliosphere is needed in order to gain an enhanced comprehension of this celestial boundary. The probe would be an interstellar probe. The Voyager spacecraft have demonstrated remarkable stamina despite their outdated technology by providing crucial data even though they were launched in the late 1970s. The space probe's ability to withstand challenging environmental conditions has gone beyond what was anticipated. The missions described showcase the human ability to progress in space exploration, pushing the limits of what is thought to be feasible. Voyager 1's future discoveries remain a mystery as it ventures into unexplored territories. As it penetrates deeper into space, it is unknown what surprises will unfold. It takes several hours for the signals of spacecraft to reach Earth, which is miles away. It's worth mentioning that despite being the farthest human outpost, Voyager achieved the greatest feat of durability by becoming the longest-running space operation in history. Subscribe to this channel for more interesting space theories and new discoveries. The latest occurrence in interstellar space regarding Voyager 1 has aroused several doubts and new inquiries, which are unprecedented. Suspicion surrounds the Voyager's actual position and if it will ultimately explore the authentic magnetic field of space. To comprehend the heliosphere, a viewpoint provided by an interstellar probe is essential. Even after many years, the Voyager missions are still giving unexpected data and advancing space exploration. The futuristic discoveries of these spacecraft remain obscure, but they could prove to be fascinating. Only time can reveal what lurks in the unexplored universe. Do you know that Voyager 2 also turned back with a terrifying find? This video on your screen will take you there, so what are you waiting for? Click now.